items. So slides are posted on our website. If you want a link to the slides, you can scan this QR code now. Otherwise, you can go to SoCal-Showdown.org, I believe it is. You can get the slides there. This presentation is recorded. We actually did a session last week on Sunday, and that one's already posted. So if you have team members that are interested in seeing this presentation, they can go see that there. We'll also probably post this session too once we finish with it. But yeah, both of those can be resources for you. And then system core units, if you didn't pick up your system core unit, maybe you came in late or whatnot, you can pick up your system core unit after the presentation and just make sure you bring an adult mentor so that way we can make sure we're giving it to the right, right team there. If you have any questions, feel free to just raise your hand during the presentation and I'll try to answer them when I can. Otherwise, we'll also have dedicated Q&A period between the different sections. If you're looking for bathrooms, the bathrooms are out this door and like directly to the left, and they should be like right in that area over there. Yeah. All right. So I guess presenters-wise, my name is Andrew Kempen. I'm a sensors software engineer at SpaceX. I'm a Team 4201 mentor. I'm also in charge of SoCal Showdown, like the field side and the AV stuff. And I was involved in the system core development at Limelight. Also presenting with me is Jonathan.
Yeah, I'm Jonathan Dow. I'm a system software architect at RTX. I'm a Team 4201 mentor and alumni, and usually you'll see me at events as as a CSA, volunteering with the Orange Hat, and I'll be covering the second half, which covers WILib upgrade from your 2026 projects.
Yep. So kind of going through the schedule. So timeline-wise, what we'll do is I'll go through the hardware side of things first. I'll go through the just like basic hardware, what to know about it. I'll also go through the web UI and just some of the things you can do there, and then also where to get help. And then we'll take a break, and then we'll go into the software section where Jonathan will talk about how you can actually port your existing 2026 code to the new 2027 system. We'll take a break, and then we'll do breakout sessions, and we'll be doing a crimping workshop. I believe the crimping workshop will be in the sandbox area. Maybe, yes, okay, getting a thumbs up from our lead mentor, Stefan, over there. So yeah, so the crimping section, the crimping like workshop will be over there. So hopefully we'll have some students there that can teach like how you can actually crimp Molex SL connectors, which as you'll find out in this presentation is a pretty important part of the new system core, just like how it's designed and things. We'll also have Q&A here, so if you have any like individual Q&A, we'll be off the stream and you can ask whatever question you'd like, so feel free to stick around here for that. And then obviously system core pickup will probably be in the main area over there if you still haven't picked up your system core unit. All right, so I guess getting into the hardware. So system core, this is the new system core device. This will be the device we're using in the 2027 season. It's Raspberry Pi CM5 based. So if you have a Raspberry Pi 5, this is like the compute module, like the version of the Raspberry Pi that's meant to go into other devices. So if you open up one of these things, you could literally just see like a little Raspberry Pi sitting in the back of here. But it has 5 CAN buses, 4 USB 3.0 ports, 6 smart I/O ports, and then 2 I2C ports and a built-in gyro. So a lot more I/O than what we were seeing before. Kind of comparing this to the RoboRio, which was what we were previously using, it's got a much better CPU, so quad-core Cortex A76 at 2.4 gigahertz versus the measly 866 megahertz we were stuck with before. RAM-wise, a lot more RAM. It's got 4 gigabytes of RAM. That's 8 times as much as it was before. And this is on the RoboRio 2.0. If you're on the RoboRio 1, you had even less RAM. Storage-wise, 16 gigabytes with the ability to expand it so you can add USB flash drives. Otherwise, there's also an M.2 slot in the back where you can actually plug in an SSD, an M.2 SSD if you'd like. Ethernet-wise, we've got an upgrade there, so it's 1,000 megabits per second versus 100 megabits. The CAN buses, we have 5 CAN buses, all 8 megabit CAN FD capable. So where you previously had to get a Canivore or a device like that to be able to take advantage of higher data rates and CAN FD, you actually just get that built in right now. This is compared to the 1 megabit connection we had on the RoboRio. So pretty significant upgrade. Not only are we going from 1 to 8 megabits per second and adding CAN FD, we've got 5 of them. So we'll talk a little bit about that and how you can really improve your resiliency to different faults through this division of the CAN buses. I2C, it's got two I2C ports. This is a little bit better than the Roborio, which had two, but there were some hardware bugs, so it was a little bit unclear of when you wanted to actually use those because it could lock up your Roborio. We do lose a couple things, so we don't have any SPI ports. So if you're using like a gyro that connected to like the SPI expansion module on the corner, you won't be able to do that. But we again have the built-in IMU, so maybe that won't be as important there. And then PWM, that's another big area. We used to have 20 PWM ports, so plenty enough to run your entire robot on them. But with all the vendors moving towards CAN and just like smart motors in general, the PWM ports have been knocked down to 6, and these are now shared with like if you have digital I/O that you want to do, or if you have analog input, those are all shared in this smart I/O bank here. Some of the highlights, so all these connectors are now latching. They're all Molex series connectors, so either Molex SL or Molex MicroFit Plus. The advantage of this over the Roborio is before you had issues where maybe your cables would come out and you had to 3D print something that you put on there to make sure that cables didn't come out, or you had to just like put a bunch of hot glue in there and hope that nothing will come out. The new connectors are actually latching, so if you're using the actual genuine Molex SL, you'll actually be able to connect and disconnect things and not have to worry about that coming out. Something else that's new is the hardware will be shared with FTC. In FTC, we won't actually be getting this to be legal until 2028. FRC is switching this upcoming season in 2027, but FTC, given that there's a bigger user base there, is going to take another extra year just to swap over, and then they'll have actually a staged rollout, and they can continue using the old hardware in like a halfway state until 2030. But kind of with switching over to this being used in FTC, one of the goals is we wanted to allow teams to have like a plug-and-play experience. In FTC, you don't actually have to make your own cables at all. You can just buy cables and you can connect to a motor, connect to your hub, your control hub there, and you can just have that plug-and-play experience. So we're seeing some of that come into FRC now, where you can actually, the goal is that vendors will be selling pre-made Molex SL connect cables and products with Molex SL. You'll start seeing some of that more be released in this fall. But we'll start seeing like pre-made cables that you can just buy, so that way you don't have to go through crimping your cables if you don't want to. You can just buy the cables and you can have the extra reliability of not having to worry about like a bad crimp there, and you can just rely on the process controls of those hardware vendors. Other things, we have the M.2 slot that I mentioned, so you can use AI accelerator modules in there, you can install an SSD, you can do whatever you want with an M.2 slot. If it's something you can do with a Raspberry Pi 5, you can do it here. So I heard some teams talking about using different, like you can use like the one that's offered by Limelight, the one that goes in the Limelight 4, the Helio module. You can use that directly in your Systemcore. Otherwise, you can use third-party ones. Whatever you want there. There's a ton of options that you can use the M.2 slot for. We're also going to see some improvements on the software side. So with there being a better CPU now, we actually get faster reboots. Right now, we're seeing about 20-second reboots versus the 35 with the Roborio. But we're expecting that to get even better as the software matures, even as it moves up to this season here. And the last really big feature is the new web UI. Kind of the goal is we're trying to switch all of FRC to be able to be something that you can do with a Chromebook. So currently, right now, if you want to do like a CTRE motor, you have to like download like the CTRE, whatever that software is. I forgot what it's called. But you have to download like the CTRE software. Only works on Windows. Same thing with Rev. There's like the Rev hardware client. Also only works on Windows. So kind of the goal is we're moving everything to a web UI, so that way as long as you have something that can access the web UI there, you can do everything you need to do with this device here. There's not going to be any kind of weird things that you will only be able to do on Windows and so on. So yeah. Mechanical mounting wise, it's a little bit weird. It's actually based on the metric system. So the reason why this is because FTC actually uses all metric as their general standard. So because of that, to make it as compatible as we can for FTC, we have a mounting footprint that works mostly with mostly in metric, but actually can work a little bit in the English system if you are a little bit careful, if you do something a little bit special there. So by default, the holes they fit M4 screws The number 8 equivalent here works just as well. So if you're putting this on your robot, I recommend designing with number 8 fasteners. Be careful not to over tighten it. You can actually crush the corners of these devices here. You don't have to you don't have to screw this thing in too tight. You're just trying to keep it from rattling off your robot. So I would recommend being a little careful when you're tightening things in there. But the way it's designed, you can actually, if you have like a belly pan that has like a grid of like half-inch spaced number 10 holes, this is pretty common for a lot of teams where they'll just buy like either like the pre-made like polycarb belly pans from AndyMark, which just has like that half-inch hole spacing, or if you make your own, you can actually you can actually mount this system core directly into that there. The hole spacing is such that it's close enough to that half-inch hole spacing that if as long as you're putting that number 8 screw into a number 10 hole, you can actually mount directly there. So that's an option if you aren't able to make your own hole pattern. You just want to use something standard there. Something else that's different with this device. Previously with the Rorio, it was entirely backed with plastic. This new one has actually got like an aluminum backing to it, and that's for heat dissipation. It's a Raspberry Pi 5, so if you're running a lot of code, you're running your revision on here, you actually see this thing start to heat up pretty significantly. So if you can, try to mount this thing to metal, either like your metal belly pan or some other metal extrusion, such that you can take advantage of that aluminum heat sinking to allow this thing to stay cooler for longer parts of the match. Something else to mention mechanical mounting wise, if you're using USB, there's actually some built-in heat set inserts here. The goal with these heat set inserts is that if you want to build like a 3D printed like thing that like ensures your connectors are staying in there, you can actually like 3D print something and like use these two, or like it's a little bit different. This is what the actual device looks like. This picture is not quite accurate, but you can use these two heat set inserts to retain positively your USB connections if you're using anything like that. All right, connectors wise, as I mentioned, the two connectors that are new on here are the Molex SL, so that's like all of your CAN bus connections, your your RSL connections also Molex SL, all of your Smart IO, all your I2C. In the kits that you guys will be getting, actually, well, I'll get into that later. Oh yeah, and then Molex MicroFit Plus. This is going to be more of a standard in FTC. Kind of the goal for FTC is we want teams to be able to plug in one cable from their control hub to whatever motor. So this one is actually an odd cable for FRC in that there's only 2 pins that you'll use because it's like the power input for Systemcore, but there's also 2 pins on there that are exposed for the FTC use case where they actually want like a CAN connection from Systemcore here to MotionCore, which is like the other part of this for FTC. So because of that, we have an extra 2 pins here that just won't be populated, but they will be used in FTC. But these cables, these MicroFit Plus cables, the goal is in FTC, there's going to be a thing called MotionCore. If you've looked at the FTC blog, you can see more pictures about that. But it basically just has like a ton of MicroFit Plus connectors, and each one of those, the idea is you can connect one-to-one to a motor and then have your CAN connection and also your power to that motor. So that's why things might look a little weird with that connector, at least on the FRC use case. Then, as I mentioned, there's not a lot of stuff out right now for these connectors. CTRE in particular has some stuff out, but we're going to, as soon as like the September, October blog post from First comes out, we're expecting to see a lot more vendors start releasing products using these connectors here. So for now, you're going to be kind of stuck using either the connectors we give you or making your own connectors, but hopefully by the time we get to the season, you should be able to just buy stuff and like have it so you can just connect things as you desire there. All right, and then yeah, so what you guys will be receiving, so you get a beta system core unit. You can tell it's a beta unit because it has the silk screening. I don't have an alpha unit here, but if you did have an alpha unit, it doesn't have any silk screen on it. So if you're looking at documentation, you're not sure which one you have a beta unit. So make sure you follow the beta unit documentation. There's a little bit of things that change between the alpha and the beta here. This unit is yours to keep, so you will have an extra one going into the season because every team will be getting a system core in their black tote that you get like during kickoff. So you will actually have 2 system cores, the one you get now and the one you get then going into the season, which is a pretty big advantage. You also will be getting one Molex MicroFit Plus cable. for your power. So this is a cable that just connects into this microfit plus here and has just a twisted pair that terminates in just like bare wires. And this one you can plug into your PDP or PDH to supply power to this Systemcore device, just in the same way you would for your Rio power. Then you also will be receiving between 4 and 5 Molex SL 2-pin CAN cables. I believe all the teams this week will have gotten 4-pin or 5-pin or 5 of these cables. We were short a few cables, but I think some of the teams last week were just like, hey, we use Molex SL already, so we'll take the 4-pin ones. But yeah, the idea with these ones is you can use them for all your different CAN buses as you start rewiring your robot there. All right, some of the things you don't get, so you will need one 2-pin cable for your RSL. If you want, after this, during the crimping workshop, that's what we're going to be building. So if you don't have Molex SL crimp tools, I recommend sticking around for that, and then you can at least build that cable out. And then you can have that, and you can bring that back to your shop and connect your RSL to it. But if you don't use this Molex SL, you should be able to use your 2-pin DuPont connector that you used previously for your RSL. It just won't have that extra latching feature. I guess that's kind of a nice note. These Molex SL connectors are kind of unique in that you can actually use like the more standard, like the more that you might have used previously, these DuPont style connectors. You can actually put them into these plugs and they will work just fine, but they won't have the extra latch that you get with the Molex SL. So if you are porting your robot over from RoboRio to Systemcore, you might be able to just connect your connections directly. The pinout should be the same between Systemcore and Systemcore and RoboRio, so most of the connectors will just be like straight connect back to Systemcore. But yeah, that's there for you. The other thing you won't be getting is a 3-pin Molex SL cable. So this is for if you're using Smart IO. Smart IO is a 3-pin connector. It has a signal, positive and ground. So there's 3 pins there. And then the other thing you won't be getting is that 4-pin Molex SL cable. So if you need that, you'll have to find that in DigiKey. I think before the workshop I sent out those part numbers just in case you're looking for them. But this is only really a thing if you're using I2C. All right, note about connector plating. So this is something we really haven't worried about in the past, but with Systemcore, we're trying to make a push to try to standardize all the vendors across FRC around gold. So all the connectors on Systemcore will use gold finish. So if you're buying contacts, make sure you buy connectors with gold finish. So kind of a note here, you gotta make sure that you don't mix gold and tin. There's a material incompatibility between those that will cause a tin oxide to build up. And as your robot vibrates or the connectors are mated and demated, you'll see wear on these connectors. And that can, over time, lead to not as reliable of connections. So just something to be aware of there when you're buying connectors. Make sure you buy gold finish. Unfortunately, there's a star here because our batch of beta units are slightly different from the actual season ones in that the Smart IO and I2C ports actually have tin-coated contacts. And the reason why is just because on the quick timeline that we need these units for Systemcore, so that way you guys could get started in your robots. There just wasn't enough gold contact or gold-plated contacts out in the market. So just something to note, the ones you will get will have tin contacts. So in this case, you actually do want to use tin on these. So if you have gold, you can use them, but it's just something to watch out for if you are using gold on tin, because this will be like a issue over the course of years if you continually use these Systemcores, as we hope you will do. So yeah, just something to note there about the tin versus gold there. If you have questions about the specifics of that, I can definitely answer that after this. Then CAN buses. So as I mentioned before, we have 5 CAN buses. All of them are 8 megabit FD capable, and they will default to, we're expecting that the default will be 5 megabits. There's still some things that are changing, and I'll talk a little bit about the software versions, but this is one of those things that's still kind of in work. So yeah, all the CAN buses are selectable in speed. So you can see in this this picture down here in the bottom left or bottom right here, there's actually a couple different speeds of CAN FD or CAN buses that are displayed here. So we have some that are 5 megabits, some that are 1 megabit, and some that are 8. This is something you can actually configure in the web UI. So So you have to be a little careful with this though, because many devices actually don't support the full 8 megabits per second. So you have to kind of watch out for that. You'll have to look at your specific vendor and see what they recommend for your CAN FD speeds, but you have to make sure that all your devices on your CAN bus support whatever speed you select. So if you have some older Rev products or some older CTRE products, they probably don't support full 8 megabits CAN FD. They might only support 1 megabit or maybe 5 megabit. So just make sure if you have some of those devices on your bus that you've chosen the lowest speed that all the devices on the bus can use. Something else to mention, some of the SPI buses are actually shared. So in particular, S0 and S1, and then also S3 and S4. These ones are on shared SPI buses. This shouldn't be an issue for the average user because all the CAN buses can still like get pretty good data rates. Like you can see here that we're actually able to get like 5 megabits on both these buses here, and we're only using about 85% of both of like their total capability here. So I wouldn't worry too much about it. You might see some people on Chief Delphi that are really concerned about it, but in general, you won't run into this issue unless you're like trying to like put like, I don't know, 100 motors on one CAN bus or something like that, something like really crazy. But if you're trying to do like a more like reasonable division of like having like about 5 to 6 devices per CAN bus, this is not even a concern, like not even a slight concern. And I mean, you're able to run entire RoboRio CAN buses off of 1 megabit. So you can definitely hit that. If you switch to 5 megabits or even more, like there's tons of capability there. And then if you do run into any issues, so if you connect all your things and you have 200 motors on 2 of your buses and it's causing issues, you will see it in the web UI. So don't worry too much about it. Unless you're seeing an issue in the web UI, you should be able to do whatever you'd like there. Yeah. So I guess now we'll talk a little bit about fault tolerance of the CAN buses. So this is a typical RoboRio CAN bus. I think we've all wired something similar to this in the past. So you have like your one connection that you have into your RoboRio, and then you go through all your different devices, and then you go to the very end and you terminate with a 120 ohm resistor between the CAN high and the CAN L. Or you go into your PDP and that does the same thing because it actually has like a termination built in. If you, some teams would add a Canivore, and that's like about a $300 device, and that allowed you to have separate CAN buses with higher data rate. Can anybody tell me what happens if you lose a connection in this CAN bus? Yeah, thumbs down. Whole CAN bus is gone. So you take any fault, like any connection in this loop, and you lose every device. That is just, unfortunately, the reality of this system here. It's a daisy chain topology, so any connection results in this loop that needs to be closed being disconnected. And I think we've all been there, right? We've been looking at a robot and we've seen the CAN bus get yanked out, and then we're like, oh no, it's sitting in the field dead. What can we do? And there's nothing you can do, unfortunately. You're just dead in the water there. Yeah, so this is why you got to make sure you protect your wires and you do a really good job there. But unfortunately, taking things disconnecting, connectors not being put in right, this is just a reality of the competition we build. There's just things that are constantly changing. People are putting things together that are new, so it's just kind of a reality. With the new Systemcore, you actually get access to 5 CAN buses. So instead of doing what you had to do before, where you had all your devices on one CAN bus, you can actually divide them up into a bunch of different CAN buses. So over here on the right side of the screen, I show like an example implementation of what I would recommend you switch to. So in this example, we have the S0 bus connected to your drivetrain. We have your IMU and all your swerve modules, and then we have that terminated. So this can be either PDP or PDH. And then we have all your other mechanisms. So maybe if you have like a turret or a shooter, you have your 3 motors on that, and then you have your termination. You can have maybe some kind of like intake pivot or something. You do your 2 motors, maybe your encoder, terminate that bus. If you have like a uptake or die rotor, that could be another one of your buses. And then the last bus here we have is just only our intake. So the reason why this is a good thing to do is if we take a fault on a bus, the only thing you lose is the devices on that bus. So now we have a much better tolerance to faults. So in this case, maybe we lost our intake, it got ripped off or something, but guess what? You can still do everything else in your robot. You can still drive, you can still use your shooter, you can still intake. So this is why switching to 5 CAN buses is such a powerful thing, and it's going to really improve reliability. So highly recommend if you're rewiring your robot to split your CAN buses up between mechanisms. It does lead to some silly things where maybe you will have a CAN bus that has a single motor on it, like that S4, but this is a good thing because if you do lose that intake, and we've all been there, the intakes are always hanging out of the robots, so they're always the first thing that gets taken out. This is the only thing you'll lose, so you won't have to worry about banking up your faults into one bus where you can lose a single connection and then lose like multiple things. You can just have it so only the one thing that's dangerous and that could get broken is isolated there. So yeah, this is what I would definitely recommend if you're rewiring your robot. Try to follow this methodology here and try to split up your mechanisms one per bus. But I say all this stuff just to recommend what like the ideal thing to do is. If you're trying to go quick and you're just trying to get your robot switched over, you can just connect your CAN bus exactly how it is to the system core. And that's totally fine too. You just won't take advantage of this extra fault tolerance that you can get with the new system core hardware. All right, screen. So one of the things that's pretty cool about this new device here is we actually have a little OLED display that's built in. And this one will actually tell you some different debug information about your robot. Just something to note, this screen will turn off after a minute of inactivity. This is due to some issues with some of the early alpha units where there was an actual hardware bug that would cause the screen to burn out over time. So to kind of resolve that via software, they just made it so the screen would turn off automatically after a minute. If this does happen, this is normal. Just tap your system core, and it should wake back up there. It uses the IMU to detect when it's being moved or shooken, and then it will actually wake up there. But this screen displays a bunch of useful information. So it has your voltage of your battery. It has your team number listed here. It has the IP address for your Wi-Fi interface, for your Ethernet, for your USB. I'll talk about this a little later, but there's a lot of different ways you can connect to your system core nowadays. It has like all your CAN buses and what the state of those. It also has all of your I/O ports and what the state of those is. We're expecting this screen to change over time and there to be even more debugging information put on it. So eventually the goal is you'll be able to just look at your screen and try to figure out what the fault is with your system core if there is a fault. Some of the lights on the left here are pretty useful for debugging too. So the top one there is the power good light. So if you see that one turn off, something is wrong with either the internal converters on your device or upstream. Maybe you got disconnected something on your robot. We also have a robot signal light indicator. So this one should blink the same way as your robot signal light. So if you don't have that installed for any reason, you can look at that and you can understand what the state of your robot is. Then we also have a fault status. That's that bottom one that's turned off. If there is a fault, you'll see it turn on red, and that's how you know there's something wrong with your hardware or something you need to look into. If you do see this turn on to red, the first thing I recommend doing is going to the web interface. The web interface can give you a lot more information about what specifically is broken. So this is just kind of an indicator of like, hey, something might be wrong. Go to the web interface, and then it'll tell you like in more information what actually is wrong with your unit. All right, so connecting to your system core, we've got a lot of different options now. So you can do it just like you would normally. So you can have your VH109, for example, and you can connect that into your system core over Ethernet, just the same way you would for a RoboRio, just directly into that Rio port. You can also connect over USB-C, so it's just like how you did before, where you would connect over the USB-B, or yeah, USB-B cable, and then it would show up, and you could like drive your robot over USB. You can do that same thing here as system core. You can connect over Wi-Fi. So this is mostly targeted at FTC. For FRC, you won't actually be able to do this because we'll disable it as part of like your, I think like probably the configuration for a competition, but you can connect over Wi-Fi. So you'll see like this system core Wi-Fi, or if you rename it, you can change it. The password is really secure. It's all caps password by default. So if you're trying to connect to that, that is the password there. And then obviously you can connect over Ethernet too, just the same way you did before with your RoboRio. Something that's new, before you had to remember this like kind of crazy MDNS IP. It was like RoboRio dash team number dash something dot local. No longer. You can actually just use this robot.local MDNS name, and that will always work no matter what your robot team number is configured to, or if you're connected over Ethernet or the Wi-Fi or whatever it is. those will always tell you, that will always go to the right IP address. And if it doesn't for some reason, the information for how you connect to the IP addresses is actually displayed on the screen. So you can look at the screen, you can try to figure out what IP address you should actually use if it isn't working for any reason. Like, for example, you have 2 robots connected, or something is not configured right in your computer. And then something else I'll mention here, this Systemcore quick reference is pretty useful. I'll talk about this in just a moment, but this Systemcore, under the Systemcore testing repo, there's this little table here, and this has just like a quick guide for all the different IP addresses, what the default login for each of these devices is, what the name of all the CAN buses is. This is just all available here in this nice quick start guide. All right. Something else to mention, if you're using your VH109, make sure you switch to Systemcore mode. What this does is normally the 10.t.eam.2, so like if your team number is 4201, it'd be 10.42.01.2. Usually that IP address is assigned to RoboRios. This is just so that way the field system and like other software knows that it can go to this .2 IP address and it can find your system or your RoboRio. So that's normally the way it is. When you connect your system core by default, the radio will be looking for OREO, and it won't see that, so it will assign it some other random IP address. So you might get like 220 or something else like that. If you are seeing a weird IP address or you're seeing some other weird communication issues, make sure you check your radio and make sure you have this little checkbox here, this enable system core mode checked. What this will do is it will make it so that your VH109 assigns the .2 IP address to your system core. So if you're seeing something weird, or maybe you look and you see that the IP address for your system core is not a .2, this is probably what the issue is. So make sure you check this here. All right, I guess we'll pause right now, and if anybody has any questions, feel free to raise your hand. I can definitely answer that. Yeah. Yeah, so Fuzz asked about if you lost a connection in your CAN bus, what exactly happens? Like, is it all your devices downstream that you lose, or some of them upstream? And the answer is it's kind of a little bit of a mixed bag, unfortunately, depending on exactly how it faults and whether or not it's like a high impedance fault or if it's like something that's shorted. You can lose a different number of devices. There are some cases where you'll be able to communicate with all devices up to the fault, and then some of the devices not after the fault. Or it's just a little bit weird just because of like the specifics of how CAN talks, but in general you can kind of assume that you'll lose all your devices, and if you do get some of your devices, it's because you're lucky in some way. Yeah. Yeah, questions? Yeah. Yeah, so question is about if you can extend the number of DIO ports. Unfortunately not. The only way you can extend the number of DIO ports is if you add like an external microcontroller or other device. There are some devices, I think from like Lumen Labs in particular, that they have like a device that just like can connect to a bunch of different devices, and that's something you can connect over, I think, like Ethernet or USB. So if you do need more DIO, that might be an option. Yeah, otherwise there are some like I2C like GPIO expanders that you can use. That might be another option. Whatever you can do with Raspberry Pi, if you can search up somebody like connecting a ton of I/O to a Raspberry Pi, you can probably do that here too. So you can find like a USB GPIO expander or like maybe an I2C one, and you can get a lot more I/O that way if you need it. Yeah. More questions? Yes. Yeah, so the question was about, for all of us that are Imperial. I think pretty much everybody here uses Imperial. For us, yes, it will be 832 is the screw type you'll want to use to fasten your system core down. They are not. If you try a 1032, it will strip things out and make things not happy, but a number 8 screw will fit perfectly, so I definitely recommend using 832. 1032 will look like it'll fit, but it's not quite a fit. It'll actually thread in and not go in nicely, so don't use 10, use number 8 for this. If you have VEX hardware, all the VEX screws and things are like the classroom kits. All those are number 8. So if you need a number 8 in a hurry, you can probably look for that and see if you can steal one of those. But yeah, more questions? Yeah. Yes, yes. I'll show that in actually just a minute here. Once we get into the UI section, I'll show you off. But yes, the question was just about like whether the UI will tell you exactly where the fault is, and yes, the answer is yes. It'll tell you exactly where the fault is. So yeah. More questions? All right. I guess we'll go into the actual system core hardware side of things. So, all right. So I'm going to switch to this web UI here, and I will show off some of the cool things you can do with this web UI. So kind of as I was mentioning before, I'm actually plugging in my system core for the first time here. So you'll see the amount of time it takes for it to boot up here. But one of the cool things about this system core UI, which I've shown here, is yeah, you can go to like this 10.42.01 address just as you would normally. This is for 4201, so you obviously wouldn't have the 42.01 in the middle of it. You would have your team number. But you can also use that robot.local IP address. So that's actually the one I will use in just a moment here to connect to my system core. All right, so now that my system core is booted, I can go to this robot.local here, and we should see that our system core pops up. So this is kind of the first screen that you'll see on your system core when you connect to it. This is like the app screen in some ways. So the idea with this is you should be able to add apps, and those apps will allow you to take on different functionality and like have it available in this web UI. So by default, we have this block editor. This is mainly focused at the FTC level competition, but the idea is if you wanted to, you could program your robot using this block editor. It's pretty simplistic, so I highly do not recommend you use this for your FRC robot. In fact, it's not even finished, so don't even try using it for your FRC robot. But if you were crazy, you could use this for your FRC robot. Do not recommend. But if you do, it does generate Python code here, so maybe you could try to start here, and then I would not recommend it, but this is kind of cool. So this will be the replacement for like the Blockly editor that we see in FTC. Once this gets built out, maybe closer to the season, or maybe actually closer to 2028, this will be like another option that you have to program your robot. This is just kind of a cool little demo of the sort of stuff that you can do in the web browser. So this is just like in the web browser here, nothing I installed, and you can just go to this IP address here and you can get access to this. Something else, this is probably more useful for FRC, is you can get your Elastic dashboard on your robot here. So you can just go to this IP address and you have full access to your dashboard here. So you can build out your driver station UIs, all that sort of stuff, and you can have it directly just hosted on the system core. And then if you're switching between driver station laptops or anything like that, you don't have to worry about like, oh, the driver station dashboard was on the one computer. Like now, how do we get to the next one? It's just available on the system core. So this is something that might be useful for teams. So you can set up all your dashboards, have all your cool graphs and things, and have it shared between all the different people using your system core. You also have access to the terminal, so if you want to poke around and do things, you have full root access. You can do things in here. I highly recommend, unless you know what you're doing, not to mess with things in here, but it is an option if you'd like to mess with things, you can do that. It's a full Linux system, so you can do your system CTL stuff, and you can look at what processes are running, all that sort of stuff, just like normal as you would for a Linux device. So that's kind of cool. As all this stuff is exposed, you can follow a lot of the same tutorials you could for Raspberry Pi, and it will apply here. Maybe not precisely because the OS here is customized for FRC, but you kind of get the idea. It's a Linux box. You can do all that sort of stuff. The last thing you can do on this page is you can add a package. So I'll show off how you would add a package now. So if you're trying to add packages, and just in general, this system core repo here, the system core testing repo, this is the place you want to be if you're doing anything in your system core. This is the place. This GitHub repo here has all the documentation for like the system core specifications. So if you wanted to understand more about like what's in your system core, like exactly what GPU is in here, all that sort of stuff. Or if you want us to understand like what the ESD protection is, all that sort of stuff is in this system core specifications document. So if you have specific questions about like what is actually the hardware, you can look there. There's some documentation on like what like the standard cable spec is. So if you're trying to understand what vendors will be coming out with, what cables, like what the plating will be, what like the crimp configuration will be. This is a good place where all the stuff is documented about what the new standard is for vendors to be following, and like what the pinout is, how you want to test things, all that sort of stuff is all specified in here. This is mainly focused at vendors, but it's kind of cool just for FRC teams to see, because you can see like this is what the vendors are building to. So if we want to try and match their level of quality and how they build their cables, we can look here and we can see how they're doing that there. And then there's some details about the motor. We don't use the A301, but that is here. And yeah, this kind of shows the difference between the alpha and the beta units. The alpha units don't have silk screen, so you can see they're just like plain like this. Our beta units will actually have all the silk screen on them, as you might see from your if you picked up your units. But yeah, that's there. Kind of going to here, this is some more useful stuff for you. So this has a link to the WPI lib installer, the driver station, and then also this OS releases. So if you need to update your system core, this is the place you'll go for that. It also has some documentation about all the different vendor specific stuff. These things right here, they link to specific MD files. Those MD files are up here, so this is another place you can look for them. So if you're using, like for example, Rev products, you'll want to come to this system core testing repo, and you'll want to click on this MD document here to understand some of the more specifics about what firmware version you need to use, how you need to update your motors, what kind of API changes there are, all that sort of stuff. And same thing for all these other things here. So if you're using CTRE stuff, make sure you go here and check out this CTRE document. If you're using Path Planner, Choreo, any of that sort of stuff, like check here, because this will have specific instructions for what you need to do for 2027. Because in almost all cases, the process is different just due to the new updates in the software. So make sure you come here if you're trying to get started with any of the software things. But in this case, we're going to go to the Rev MD document here, and it tells you about like, okay, there's a new Rev lib that I have to install. So if you're getting your vendor dep, make sure you use the 2027 vendor dep here. It also talks about the new hardware client, and something else that's kind of neat here. It links this little document here, this IPK file. These IPK files are actually the file type that's used by Systemcore as like their package type. So if you see an IPK file, that's something that's specific for your system core, and it's something you can add as like an application. So we'll go through that process here of just like downloading this IPK here, and I'll show you how that's done. So we can download that IPK file here. I've downloaded it here. And we can actually go to our system core now. If we go to this add package button here, it'll say click to drag and drop an IPK file to install it. So we can go ahead and we can click here and we can upload our IPK file. So I'm going to upload our Rev Robotics Hardware Client IPK. We'll go ahead and let this thing install. It takes a moment or two. It has to go through this whole Linux install process, but it's kind of cool. It actually shows you all the logs and it can tell you what's going on here. So if you run into an issue, the first place I look in this log here and try to see if there's anything that's like obviously broken there. If that doesn't work, I'll tell you a little bit more about where you can go to get help kind of later in this presentation. But we'll let it go ahead and install. Looks like it's starting a system CTL process here. All right, and now we get green, installation is successful. All right, and now we have this new app here, this Rev Hardware Client 2. And if we click on that, we actually get access to the hardware client of Rev. So if you have any kind of Rev motors plugged in and that sort of thing, previously you had to go get the USB cable and you didn't have it or whatever, there's that orange one. Well, now you don't have to do any of that sort of stuff. You can just directly work with your Rev devices in the web UI. So if I went to like this telemetry, there's like the Advantage Scope, that cool UI that you get. There's actually all your devices are enumerated here. You can update your firmware, you can like configure the settings, all that sort of stuff. Just like you would from the Windows application, but now just on the web UI. So it's pretty cool if you're using Rev devices, and we're hoping to see some of this happen on the CTRE side with some of the other vendors too. But yeah, that's kind of the process for installing an IPK file. Something else I want to show off here is this section up here. This has a lot of the same information that you would see on the screen, but it also has this little thing up here which tells you if there's any faults in your device. I actually have a pre-beta unit, so it has some soldering issues and some other things, and the IMU is actually faulted on here, and that's why we're seeing this exclamation point blinking here. But normally it would be gray and not blinking. But if I mouse over here, you can actually see, yeah, my IMU is faulted, and it's showing that the IMU is faulting. It's at like what 274,000 faults, so it's definitely broken. If you see something like this and it's not something you did, reach out and we can try to help you fix your unit. But you can also see all the other faults here, so you can see like if there's something wrong with the brownout, the I/O. You can also see if there's something wrong with your RSL. The RSL is a little bit unique now. It will tell you if there's something that's faulty with it, like it's shorted or something. But that's like the same fault area as like being unplugged. So in this case, it's grayed out because I actually don't have an RSL plugged in. But if I have one plugged in, we should see that like turn white, and then it'll tell you if there's something shorted or something else is wrong with it. But yeah, there's a bunch of other things on here, so you can see the history of if you've seen any faults since this device is booted. So if you're seeing something that's like transient, you might see it show up in this fault history and not in the current fault status. But yeah, if you're having any issues with your system core, or you think there might be something wrong, this is the place I would go first. If you're using too much CAN or anything like that, this is the place that will alert you, and it will show up as red. So if I have 300 devices on my CAN device, on my CAN bus, and they're getting sluggish and using the bus too much, this is the place you can go to see if that's happening, because it will actually tick up the number of CAN errors, and it will actually tell you what you need to do to try to fix this, whatever issue you're having. Yeah. Something else I'm going to show off here is this configuration screen. So this configuration screen is where you configure all the different information for your system core. There's currently a place where you can enter your team number. If you want to, you can enter that. That will make it display as like your team number on display and things. But we're actually expecting once we switch to Alpha 14 that you won't have to configure your team number anymore, which will be really helpful for if you're trying to switch between different like team numbers at off-season competitions or anything like that. Um, but yeah, so you can go through, you can configure your team number here, you can configure all your Wi-Fi settings, so you can configure your SSID, your password, all that sort of stuff you can configure here. You can also configure all your network interfaces. All this stuff that's in here by default is what I would leave it to. The only thing I would really be changing on this screen here is like your password, your SSID, your team number, and then this last section here, the update section. So this is something we're going to be running into, I think, a couple times during this time leading up to SoCal Showdown. Currently, the units that you're getting, they have this Limelight OS Beta 12 installed in them. Beta 12 is the first version that allows for these over-the-air updates. So I'm actually going to show off the over-the-air update process. Yeah, but um, if you have older Limelight devices, you might still have to use like the Limelight System Core or the Limelight Hardware Manager to flash those. But starting with System Core in this update here, Limelight devices will actually be something you can update over the air and not have to do like the USB cable, like press the reset button and try to get right there. This is actually something you can do entirely using the web UI, which is pretty cool, I think. So I'll show what that process is. So we'll go click on this select file, and then we'll download. Once we have the Limelight update or the .ll update file downloaded, you can click here and you can update it. So we'll upload that, and we'll click on this flash update. It'll ask us if we want to apply our OS update. The first time you update your system core, you're going to be updating from version 12 to version 13. This update is like a destructive update. It doesn't allow you to save your robot programs or anything like that. Everything you install will get wiped. So there's just something to note. The first thing you do when you get your system core is I would just update it to version 13. So that way you're not wiping away anything in the future. The update from version 13 to version 14, which we're expecting to release in the next couple weeks, or at least definitely before before SoCal Showdown, that one shouldn't be as destructive, and there should be options for you to save parts of maybe your code or maybe your apps, not lose all that stuff as you do that update. But in this case, we're going to click OK because we don't mind losing our stuff. And then now it should go through the flashing process. One of the first things it checks is this link speed. Just something to note, if you're connected over not Ethernet or you're connected over like Wi-Fi, for example, it might be a little slow. And if it's too slow, it'll tell you like, hey, I can't update over this. It's going to take forever and we're going to have errors. If that happens, I recommend switching to either USB or Ethernet. So that way it just has a much faster connection there. But yeah, we'll let it go through this process here of updating, and then hopefully once it's at the end, it will give us a success message. And once it does get through that success message, the first thing we'll have to do is we'll have to reboot our system core, or rather reconnect to our system core. If you're connected over Wi-Fi in particular, you'll disconnect from your system core, and if you just keep refreshing the page, you'll be like, why is it not finished updating? It's because you're not connected to it. So if you're over Wi-Fi, after you flash it, make sure you go to your Wi-Fi networks and you reconnect to your robot network, because it will be like a new network. It'll be something you'll have to connect to with a new password and that sort of thing. All right, looks like we got our boot image flashed. Now it's going to go through the root file system. While we're waiting, I'll just show off where you get these images. So the place you can go to get these images, again, is the Systemcore testing repo. So starting from the top here, we'll scroll down to this section here under the software. And under this OS releases, toolchain, this sort of thing, this is the place you'll go to download any OS releases. So we'll click on that link, and this will bring us to a different GitHub repo. This is the Systemcore OS public repo. This is the place where we'll see updates get posted. Something to note, the most recent update right here is the one that's under this releases tab here. This is version 13, but as I was mentioning before, if you're trying to download this, by the way, the place to download is this .ll update file here. The .zip is for if you're using the hardware manager, but since we can do over-the-air updates, it's way easier. I definitely recommend using this .ll update file instead. But yeah, you can download this here. But kind of as it says here, Alpha 14 and Beta 14 are in progress. These will require WPI-lib Alpha 7. So when we do go to this like big switch to Alpha 14, right now the WPI-lib that's out is Alpha 6. So you'll have to do two things when you update to Alpha 14. You'll have to update your WPI-lib, like go through the update process there, and then you'll also have to update your Alpha 14 at the same time. So this will be a bit of an update process, but it will be pretty useful because there's going to be a lot of changes between Alpha 13 and Alpha 15, or Alpha 14, sorry, in the hardware side. We're going to see that the UI will get a lot more fleshed out. We'll see a bunch of different features that we don't currently have get enabled. So when this does come out, it will be required for SoCal Showdown. It's something you'll want to update to before the competition, so you can take advantage of all those extra changes. And you can see just like a small list of changes here. Like there's a ton of stuff that's coming out in this version 14 here, and this stuff is going to be pretty awesome. So we'll want this as soon as we can. All right, hopefully by now this has finished. All right, looks like we see our update applied. Our system core is booted, and now we can refresh this page. So now if we refresh, we should see that we have a new screen with slightly different things on it. So back to our home screen, our Rev hardware client unfortunately got uninstalled, so you have to go and reinstall that now. But hopefully this will be the only time this happens. We can now, I guess we'll go into the system tab and I'll show off some of the things here. So system tab here has some pretty useful information for just understanding the state of your system core. So it has like temperature, CPU utilization, RAM, that sort of thing. It also has your CAN bus utilization here. So if you have any kind of CAN issues or anything like that, you should see that appear there. So yeah, this has all the different bandwidths and things that you're using there, all illuminated like this. So that's something you can look at to understand how much of your CAN bus you're utilizing. It also has just like information about what your CAN buses are configured to. So if you need to reconfigure your CAN bus, this is a place where you can do that. We also have a place where you can see what the current IMU status is and like what it says your system core is doing, just that way you can debug it and make sure that's right. Obviously, we have a bunch of faults in our IMU, so if I move my system core, it's not actually going to move this display. It's just going to show all zeros. But if this was working, you could actually like move your system core and you would see this little graphic update with like what it's actually doing. Let's see. Then the other useful thing here is this I/O tab here. So under this I/O, by default, we have all digital inputs and outputs configured. I had a little device that I was going to use to turn on and off these digital I/O for you. But if you actually like plugged in like device and you like connected and disconnected like a limit switch, for example, you'd actually see this little green thing turn on and off, which is kind of cool. So this can be a way that you can really quickly verify if the hardware is working. Previously, you had to go into your software and you had to like write some way to like log your limit switch value, and then you had to look at your UI, and there's just like a lot of things there that could break, and you weren't sure if it was the hardware or the software. Well, now you can have your hardware team just go into this web UI and they can just verify, like, did my limit switch get plugged in correctly? They can click it, make sure it works, and then now you know if there's something that's wrong. It's between the software and on the software side, it's not something on the hardware side. So that's pretty useful. Um, if you're using something other than digital input and output, if you're running running your robot code, you should see these get reconfigured to whatever your robot code is using for each of the smart I/O. Because I don't know if I mentioned this earlier, but smart I/O you can configure like per smart I/O what type you want. So it's going to ask us if we want to stop our robot code. We'll say yes. But once we go here, we can actually go ahead and reconfigure our device I/O type. So if we want to use, for example, analog input, now we can see the analog state of our signal here. Nothing's plugged in, so we're just kind of seeing the noise of the ADC here. But if you did actually have something plugged in, you can rotate it, you can verify that it's outputting the right value and that sort of thing. We also have PWM input, so you can see your pulse width, your period there, if you have some kind of PWM input sensor. We have our counter, so you can see if you have like a quadrature encoder or something plugged in, this is the way you can see what the current count is. And then last thing is the counter falling. So all those sort of things are things you can configure here, and you can change per device what you want each of these to be configured to, and you can actually see if your hardware is working just by looking at here. So that's pretty cool. All right, we'll click done, and then it will restart the robot code and go back to normal. Other things that are on this UI, we also have this USB devices and PCIe devices, I2C devices. So just if you're plugging in USB things, like currently I have a USB camera plugged in, so you can see this enumerated right here. This is where you can see some debug information about what stuff is plugged in there. And then PCIe devices, so this would be like your ICE. If you have like an M.2 something plugged in, this would be where you would see that stuff. All right. Other things that are useful here, there's a huge list of different things you can look at. So you can look at your network interfaces, your interrupts, your processes, your services, all this sort of stuff. For each of these things, you can dig through, you can poke around. This is all just like bare Linux stuff that's being exposed. So if you want to see like the state of like a system D process, for example, you can click on this UI and you can actually see like this is just like a normal system D process that's running, and there's just like a nice UI that's built around it. So that way you can understand from like more visual perspective what's happening to all your services here. Let's see, other things. There's a CAN bus monitor. So if I had some CAN bus devices, I could actually see like Wireshark style, like every single packet that's being sent in the CAN bus. So if you're developing your own CAN bus sensor or something like that, and you want to debug to see if it's sending the right information, you can actually use this to debug that. There's also a way that you can like upload specs. So just like in Wireshark, how you can like update a thing that you can like upload a thing that will like interpret the fields and tell you like what each field means. You can do that same thing here. And if your vendor is like Rev and they have like a spec uploaded somewhere, you can actually upload that and you can see like every part of what your CAN bus is saying, like what the sensor readings are, if you're enabled, disabled, what the power reading is, all that sort of stuff you can see at the rawest level here, which is pretty cool. Let's see, there's also your storage devices, so you can see how much storage you're using. If you have a flash drive plugged in or that sort of thing, you can see all that storage stuff here too. And I think the last other interesting thing is the package manager. So this is another place you can install IPKs. This is also where you can see the versions of what you have installed and also remove things if you need to for any reason. But yeah, these are definitely all cool little tabs. I would definitely recommend poking through them if you have time. The next tab down is Motion Core. Motion Core is the device that's used by FTC, so we won't see anything interesting appear here because we won't ever really use Motion Core in FRC, but if you were an FTC team and you had Motion Core, you could plug it in and you could see all the cool things here and you could see all your motors connected and all that sort of stuff. The other useful tab here is this cameras tab. So this is something that's pretty cool about the new Systemcore thing. It's made by Limelight, and if you're familiar with Limelight, they're the same people that make the Limelight like 4 camera, like the Limelight 3A, like these sort of computer vision-y cameras that you can use for all these different things in FRC. And what they've done is they've actually enabled that same UI that you would see on your Systemcore or on your like uh, dedicated purpose-built Limelight camera. They've enabled that here on the Systemcore. So I have just like a normal USB camera plugged in, just very standard, and you can actually see that it's showing up in this web UI. So if you want to wave hi, you're on the stream here. But yeah, this is the same web UI that we might be familiar with. You can change like your pipelines. So you can do things like April tag detection. You can do like neural classifying. So if you want to like identify what type of object is in front of you, it's telling us that we're in a sim, a movie theater. I think that's a pretty good description actually. But you can see all that sort of stuff now. You can configure just the same way as you would with the Limelight. So all the same sort of stuff. You can do your calibrations. All this sort of stuff is exactly the same as you would for a Limelight. So this is a pretty cool capability because now you can just buy like any camera, basically any USB camera, and you can have the full capability to do everything you would need to do with a Systemcore or with like a dedicated Limelight camera, and you can just do that directly in the web UI. So if you're doing light April tag detection, that sort of thing, you can do that now just through this web UI. And you don't have to like buy like special hardware or like connect in anything like that. You can just plug in USB cameras and have them appear here and be totally useful for any kind of April tag, anything you want to do. So I think that's pretty cool. That's definitely a huge plus of this new hardware. Yeah, Fuzz, question. Yeah, so good question. The question was about how like the CPU utilization is of this versus like your robot code versus like many different cameras. The answer is it'll share between your robot code and your vision system, but the way it's implemented is actually pretty smart. So if we go over to this CPU slices tab, what Systemcore, what Limelight people have done is they've created a Linux slice for the vision system. They've set the priority of that by default to very low. So what this means is the system and your user code will by default be allowed to take as much CPU as they want to, and then whatever is left over will get given to the vision system. So this should mean that even if you plug in like a bunch of cameras and you're trying to do April tag detection in all of them, you won't actually see your robot code slow down. It should just only affect the cameras. So if your CPU, if your user program needs to do a bunch of computation and takes more CPU, you'll see your camera start getting slower and slower instead of vice versa, where maybe you have a lot of cameras and then suddenly your robot starts like jittering and not moving as quickly as it should. You shouldn't see that happen. You should see the vision degrade before the robot code slows down. So just something to be aware of if you're using visions things there. The other part of the question was like how many like April tag pipelines and things you can run. The answer is it's going to kind of depend on what your settings are. The hardware that's inside a Limelight 4 and is exactly the same as what's inside your Systemcore. So you won't quite be able to do what you can do with a Limelight 4 because this thing takes advantage of all of its compute to give you your highest FPS, the highest resolution that it possibly can, and it doesn't have a robot program running on it. Versus Systemcore has a robot program running on it, so you won't be able to quite do the same thing you can do with this with like a system or like a Limelight 4, but you can get pretty close to it. So if you're trying to run slower or lower resolution, you should be able to do like 1, 2, whatever, however many cameras, just by like scaling your resolution or how many FPS you're willing to accept there. But you can do this across all the different cameras you have. So if I plug in like another camera, for example, I have a Limelight 3A. I'm going to plug that in over USB. We should see this one appear in just a moment. This one takes a little bit to boot because it's actually got a Raspberry Pi built in. This is more targeted at like FTC use cases, so it's a much smaller like device, and it has just like a single USB. But if you have FTC teams, they might be using these. These are the Limelight 3As. They're pretty nice because they're so compact. Like compared like Limelight 4 versus this, like it is much smaller camera, but it has similar compute because this device has a a Raspberry Pi 4 in it, versus this has a Raspberry Pi 5. So pretty similar compute. So if you're looking for something that has like a smaller size, this might be another option. Whoops, looks like I plugged into the wrong cable. That's why it wasn't booting up. There we go. Now it's actually got a light on it, so we should see this turn on in just a moment. Um, but yeah, you can plug in this up to 4 cameras if you'd like, and then each one of those 4 cameras will be able to run entirely separate vision pipelines. So you can configure them entirely separately. You can have different vision stuff running in each one of them, and that sort of thing. Something to be aware of when you're choosing USB cameras, there's a limited set of cameras that's actually supported currently. You can use all whatever camera you want, but it might not have like the calibration built in. It might be a little buggy, so just something to be aware of. But in this document here, it actually lists what cameras are ones that you can use somewhere here, or actually it might be in this Limelight section here. But it actually has all the cameras that you can use listed out somewhere in here. Yeah, right here. This is like the list of all the cameras you can use. So a lot of like the standard ones that you might be aware of using, or that might be popular to use, like these OV9281s. A lot of Logitech cameras, these are all supported. So try to choose from these if you're trying to use cameras, but other cameras should work. Like this camera I'm using is just a random camera and it's working. But if you're looking for the best capability, I definitely recommend using one of these ones here. But hopefully now our camera should have booted. Well, it looks like it's not booting. Oh well, that's okay. But yeah, if this was working, I would be able to show off that this would be another camera that shows up just like the same as this other one. Oops, looks like something disconnected now. All right, well, I'm not sure what's happening there. But yeah, if it was working, you should be able to see the different. Oh, that's because this disconnected. Oops. Right. Yeah, you should be able to see all the different cameras enumerated here, and just like you would have multiple cameras just available here to configure. Let's see if that's working now that I reconnected my Ethernet. Oh yeah, there we go. Now it's working. So now I have 2 cameras. So I have this camera that's doing things, and I have this other camera that's running an entirely different pipeline. So that's pretty cool. And specifically with these Limelight 3As, I think one of the things I wanted to kind of mention here, you'll see that this is a different IP address than the normal IP address of the Systemcore. Limelight has actually set up the routing and all the Linux routing rules such that like even though this device is connected over a USB to our Systemcore and not connected to my laptop in the same Wi-Fi network, it's actually got its like own IP address here. So it's a .220 versus over here, this, if you could see the IP address and it wasn't the MDNS, you would see it's a .2 IP address. It looks like my laptop's about to die. Yeah, so I know that's kind of cool. If you're using a Limelight 3A, it should just work like that. And yeah, I think that's everything I had for the web UI. Does anybody have any questions before we go to our break? Yeah. Yes, the question was if you have 3 or 4 connected cameras, can you still use your coprocessor? And the answer is yeah, you can still use your coprocessor just like you would normally. And I would recommend if you are trying to do a lot of compute stuff with your vision, you can just use your coprocessor just like normal, and it will give you additional compute. So that's pretty cool. But yeah, if you're using like an Orange Pi 5 or anything like that, you can just use it just the same way you would. If you have like Limelights that you want to use, you can use those just like you would. So you don't have to switch over to this as an but it is an option. So if you're trying to design a new robot, you're just trying to add like a new like small camera for maybe just like identifying where the balls are at the beginning of the match. This might be a quick way you could add that and take advantage of all the Limelight like classifier networks and things they put out there. Yeah. Yep, yep. So the question was about if multiple computers can connect to the web UI at the same time. The answer is yes. You can connect as many computers as you want to the same web UI, and you can have. So this is where this is kind of going to be useful for like the classroom application, because you can just have like a single system core, and you can give it to a group of students, and they can all work collaboratively on that same system core. Not currently in the web UI, but something that is going to be coming soon, maybe before the season, maybe not, is the ability to add a package that's actually your VS Code with your whole WPI lib everything installed on it. And kind of the goal of that is to make it so that you can just like use a Chromebook and you can connect this thing and you can compile your code and do everything you would with your current like VS Code setup just directly on the system core, which will make it a much lower barrier entry for teams to enter. Unfortunately, this part isn't quite done, but we're hoping that this is going to be done before the season. Yeah. Yeah. Yes. Yes. Yep. Yes. The question was whether or not all the computers will see the same thing. And yes, the answer is yes. If somebody adds a package here, everybody should be able to refresh and they will see that same package appear. Or if they change the team number, they should be able to refresh their computer and it should appear there as being the same IP address. Yes. Yeah, so the question was about the IMU, if there's like an API that's available. And yes, there is an API built in the WPI lib. I think it's the IMU API. There's like a specific one for the system core. And yeah, you can pull from that and you can use it for your odometry. Just a warning, the IMU is not quite the same level as like a Pigeon, but it's quite close. I think there are teams that have actually used it for this swerve drive as either like a redundant IMU or just like their primary IMU. And they've gotten pretty good performance out of it. But it isn't quite like the same as like a $300 Pigeon sensor. I mean, the entire system core is less, is probably about that same order. So you won't have quite as expensive an IMU in there, but it is good enough for a lot of tasks. And if you just need like a backup that you know, like, hey, will never disconnect, that's like an option. Like if you lose your Pigeon for some reason, maybe you like fall back to this. Those are the sort of things you can do now that you have like one that's built in that you know will be reliable and always connected. Yeah. Yes, the question is if I plug in like another like Limelight camera, for example, like this Limelight 4 here that I have, will it be using the same compute or different compute when we're doing like any kind of configuration? The answer is yeah, it'll be separate compute. If I were to plug in this Limelight camera, I wouldn't be able to plug it in over USB because this is a Ethernet based camera versus my Limelight 3A has no Ethernet port. It's a USB based camera. But if I did plug this in, I would plug it in just like normal. I would connect it to my Lime or my VH109, so I'd connect Ethernet into here. It would show up just like normal, like as you would expect in the previous state of things, and it would show up as a separate camera, and it would use entirely this compute for its vision processing. So if you're doing a lot of like really heavy April DAG detection, I definitely recommend investing in like a dedicated compute module for that. So that way you're not relying entirely on your system core, do all your compute. You can actually offload some of that and take advantage of like adding more compute by that. So yes. Yeah, so the question was about if like a Limelight 4 would show up in this camera tabs, and the answer is no, it wouldn't show up here. This is only for USB connected cameras. So the reason why my like Limelight specific device appears here is because it is a USB connected device. If I use like an Ethernet device, for example, it would have to connect over Ethernet, and it would show up as an entirely different IP address and things. More questions? Yes. That's a good question. So the question was about how the VS Code like ID will work. I'm honestly not sure. I'm not sure even the WPI lib people know yet. I think they're still definitely in the phase of like trying to make it work at all. But I think the goal is eventually they want it to be something that like, a classroom can just use. So I would expect that would be the goal. I'm not sure what they'll get to at the end of the season, but as with software, I expect it to continue to improve. And as people make requests of like, hey, can I use this for my classroom? It'll be prioritized and people will make it happen. It will be a really awesome capability, I think, if like you can just set down a system core and all your programmers can work on it at the same time and not have to like be sharing code or like running over each other that way. But we'll see what's going to be possible on the software side. Yeah. Oh man, these are some really, we're asking more like specific questions about the VS Code and how that will work. I'm honestly not sure. I don't know if anybody really knows right now. The WPI lib people are the ones that are working on that. So last week we had Joe Ross, but I don't think we have any WPI lib here people here this week. So I won't be able to speak too much to that, but yeah, I don't know. We'll see. Yes. Yeah, so the web UI, the question is where the web UI is hosted. It's hosted on the Systemcore device itself. So if I unplug the Systemcore, uh, I wouldn't have access to the web UI. It will still show up as my computer because it actually gets cached in your computer, but the place it actually lives is on the Systemcore. Yeah, so the question is about multiple system cores and how you differentiate them. The answer is you'll have to use the IP addresses. So right now I'm just using the robot.local because I only have one system core connected, but if I had like multiple for any reason connected, which you probably shouldn't do, you probably won't ever run into this situation because generally it's like you have a robot and it has like one system core, one VH109. You shouldn't have multiple connected at the same time, but if you did have a setup where you had multiple on the same network for any reason, you would have to go to the screen, look at the IP address, and then figure out like what the different IP addresses are and connect those individually. Yeah, so question is about like in like a production environment, like for example, you're in a match. The answer is the way you differentiate it is by which like network you connect to. So if I connect to the 4201 network, that's like the 4201 VH109, I will only see the 4201 one. I won't see like another team's system core. I should only see mine because that's like the network I'm on. Um, and then, yeah, in these cases, like the robot that local for each team would just work because it would connect to the one that they're connected to. So the answer is the differentiation happens like at the network level of like which like Ethernet you're connected to. Yeah. Yes. So the question was if you have to be on the robot network to connect to the system core, and the answer is yes. You have to be connected to either the Wi-Fi or over physical USB or over physical Ethernet. So like for example, right now I am actually connected over physical Ethernet to my VH109. Oops, I just disconnected it, but I have my VH109. I have my system core here, and these two devices are connected together. I have like an Ethernet link between the two. I have just like Rio port into this port here, and then I was previously connected using my laptop connection to the driver station port, just as you would normally. So um, I disconnected it, unfortunately, when I picked things up, but this is a physical connection here. So this is an option. Otherwise, the other option is I could connect to the Wi-Fi network. I could go find the one that is 4201 somewhere here. Well, actually, oh yeah, FRC 4201. That's also another way to connect. It's just a standard way you would connect to VH109, just as you would in competition. Yep. Yeah, so the question is if during the match you'll be able to see your dashboard and things. And the answer is yes, you'll be able to see your dashboard. So if you want to reconfigure your settings, you should be able to do that just like normal. Yeah, yes. Okay, so the question was about the difference between the alpha and beta units and like some of like the resiliency to shock and vibration. Was that the kind of question? Okay, cool. The vibration resilience should be better on the beta units. I think there's some things that were changed internally mechanically to make it just better, like especially on the screen side. Um, but yeah, it's kind of hard to say without knowing your specific vibration and shock levels. But yeah, yes. Yeah, so the question is about how well the case is versus the Rio. I expect it's better. That's one of the things that they tried really hard, the Light System team here, to make better. And actually, in the specifications document, I think they actually have a little section here which talks about some of the things they've tried to do to try and make it better. For example, like there's actually like a place where like the case now contacts the PCB with the goal of trying to prevent like chips that are coming in here from getting inside the actual PCB section. So it's definitely better than Rio. I don't know if I would trust it entirely. The conformal coating is better, the plastic casing is better, but you never know. And like chips can get pretty small, so I would do the same thing you do with your Rio. I would try to tape over your ports and generally cover it up if you're going to be drilling things over it. These chips and shavings are just a bad recipe for any kind of electrical device. But yeah, it should be better, but no guarantee, unfortunately, still. Yes. Yeah, so the question is about how the FTAs, these are the field technical staff, the people that are at the field that are going to help you troubleshoot any issues with your robot, how they are going to be able to look at the system core and understand and like help you debug things. We'll see what's going to happen there. The SoCal Showdown is going to be the first ever event that's going to be running the new FMS. This is the field management system. And one of the big things they're changing with the new one is they're trying to take advantage of some like the additional troubleshooting and like web UI, like those capabilities that are available on Systemcore to make it better for FTAs to be able to troubleshoot issues with teams and just have better visibility into like what sorts of things are happening. So we'll see what's going to happen during Showdown. I expect this is something that's going to continue to improve over time. One of the things that's really awesome with Systemcore is just like the ability to send so much telemetry because of the extra CPU. So we're expecting there to be more telemetry, more tools for FTAs to be able to troubleshoot your robot even faster. I heard about like an AI tool that someone was looking at where it could just like connect to your robot and be like, oh, that's the issue right there, and help you troubleshoot things. So we'll see what things happen there, but I expect it's going to continue to get better over time. Yes. Yeah. Yeah, so the question was for non-showdown teams. All the showdown teams receive system core units as part of their registration. For those teams that are not part of showdown, when will you begin your units? And the answer is, I'm actually not even sure. We'll see. I think it's largely up to first, and also like the hardware deliveries on Limelight's side to see when those will be up for sale. But at the latest, you'll get one in your kickoff kit for sure. But we'll see. Things are always unpredictable in the hardware delivery space. So. Buzz. Yeah, so if I was asked the question about if you could use your system core during the season, the answer is yes, you should be able to use it, unless something happens really badly with the beta units and then they're just like, okay, we gotta start over. I don't think that's gonna happen, but it should be usable during the season. Even the alpha units should be theoretically usable during the season. Maybe not as your competition robot, but definitely as a second robot or that sort of thing. All right. Oh, yeah, one more question? Yeah, so the question was about web UI in the pits, and yes, you will be able to, just like you would currently, where you can connect over Ethernet and tether to your robot, and you can access the web UI just the same way. Uh, we'll see. So the question was whether or not you have to tether manually with Ethernet. I actually don't know what the rule is going to be on like Wi-Fi. Previous years, they've said like no Wi-Fi in the pits, and it's just been like a blanket rule, and they've required that you tether over Ethernet or over USB. Just that way, there's not that wireless congestion in the area. We'll see. I'm pretty sure it's going to be the case that you have to connect like over wired connections, but we'll see what first does there. All right. If people have more questions, you can ask them during the break. But I think we'll take a break now. So let's come back at 3:45, and we can go into the next section where Jonathan will actually be talking about the software. But if anybody wants to stick around and here, feel free to ask questions. I'll be down in this area here. So yeah, thank you, everybody.
Hi, my name is Jonathan. I'm 421 mentor again, and I'll be going over the WPI Lib 2026 to 2027 alpha upgrade process. To start off, I'll kind of give some guidelines about what I'm not covering today. This is because like there's just so much to cover. And mainly the purpose of this is to make sure that everyone has a robot ready for SoCal Showdown. So what we'll not be covering is how to use commands version 3. So this is going to be a new feature coming in the upcoming season. Won't cover this. Then there's also the new op modes framework, which is the FCC style op modes. It's new from 2027, which is like a side grade that you can do for your robot code. But like it, with your current robot code, which uses like the time-based robot or command-based robot, like it shouldn't really affect you. Writing brand new code from scratch for Systemcore. Hopefully you're not building a whole new robot for the event, but if you are, you probably have like reference code you could use. Vendor-specific API changes beyond installing the new API, vendor API and um, sm like small things like that. And robot pi is like Python's just import step because this guide is mainly written for Java as C# themes. But if you're a team who wants to cover one of these topics or something I don't cover today, please feel free to reach out after this, and then we can try to figure out something out for you. So, required tools and software. So the first thing you're going to need is the WPI-Lib 2027 Alpha installer, which I gave a link for all these tool resources here, which you'll also have access to the slides after this. The first driver station, which is also a GitHub repo. The Limelight Hardware Manager, which is part of the Systemcore testing repo. Vendor library updates. Mainly, there's just the one link, which is the Systemcore testing repo, and each vendor's like own vendor dep or vendor markdown file, which kind of describes like what they're doing for the Systemcore update, and then the hardware, which is the Systemcore beta unit, which all of you should have probably gotten at this event. So upgrading a 2026 project. So 2027 changed a lot of the internal Gradle structure projects and package names, so like there's going to be a lot of changes. So when you open up a 2026 project with in the 2027 BS code, it will prompt you to run, which is this little icon here, and this should be familiar with all teams who have like opened their new projects at the start of the season. And the porter will copy your source files into no project directory that you could specify. It regenerates all the Gradle build files from scratch, and then it will try to auto-update the code with the new namespace from edu.wkLib first to org.wklib package. And it's the best effort. But you should verify the results. Like when I went through this process, like about half the things got imported properly, and the other half I had to manually figure out. It does not carry over things that you customly put into the build.gradle file edits. You're gonna have to manually do like a between those two files and add things that you want, and it does not carry over the vendor libraries. This must be re-added for the 2027 compatible version. So like what WKLib has been trying to do over the last few years has been to try to get everyone to update their libraries, because sometimes teams will have like bugs and then the bugs get fixed. So then they force like the each vendor dep to be like each year compatible, so that that you reduce the chance of running those problem events. So step-by-step import projects. So when you open your existing 2026 project in the 2027 WKLib BS code, you'll get an import prompt, and you just click yes. But if you don't get that, you press Control-Shift-P and type in the little prompt for WKLib, and then search for the import a WKLib 2026 Gradle project. And then you select the source, which is you point to the build.gradle, the path to the build.gradle in your old project root, and then you configure the project, which is just the base folder, which is where you want to save it to, and the project name, your team number, and the hardware platform. You can select Systemcore, but there are obviously options for ROMI and XRP, but that probably won't apply to you. And then you review and import, and then click import projects, and that should be pretty straightforward. Then open the new project when prompted automatically, and then it might ask you to trust the authors of that project, and just press yes. In C++ only, accept the prompts to refresh IntelliSense configurations, and then you want to re-add your vendor dependency. So on the left of the VS Code window, you'll see this little WPI icon, which is marked here in red. If you select that, it will open up the dependency manager, which you can then go to install all the correct vendor deps for that project. So you don't have to manually mess with like the JSON like URL and then importing it online. I think this will work for most repos, but I found out like maybe one or two like dependencies you might have to actually do that. But this should be a more convenient way of managing your vendor deps and upgrading your project, so that you don't have to manually go through every single vendor website to get the correct libraries over. And then one thing I'm going to add to these instructions is getting your project back into Git, because a lot of you guys will be upgrading an existing robot to work with Systemcore. But one of the problems with the importer is that it copies everything into a fresh folder just to make sure that it works. But then it doesn't copy over your Git history and stuff. So then you're going to need to reinitialize it to go back into Git or GitHub. So the steps to do this is to reuse your existing repo. In your old repo, there's going to be like this little like .git folder. It might be hidden, so in Windows you might have to go and enable like see all hidden files and folders to it. So once you copy that hidden Git folder into your from the old project root into your new project root, then you can open up a terminal window in that window, or if you go into VS Code and open up a terminal window, you can run git status to see what changed, and then Git will then show all the change files, and then you just have to do and then at that point you know that you've copied all the Git files properly. Then the optional thing is to target a branch other than main. So if you want a separate branch for all your Systemcore changes, you can do that by using this little command called git checkout -b, which is the branch name, and you could call it 2027 upgrade or something else if you want. Or if you just want to commit your stuff to main, then you can just do it without doing the step. Then you can review the diffs if you want to, or just get add a, which will add all the files, and then you add a commit message, and then you do git push to push all your changes up, and then now your new imported project will have all the Git history from the last year into your new project. Okay, and then building your robot code. One thing I did notice when doing this import project is that it might keep your old main.java file, then you have two duplicate ones, so that when you build it, the build process will get confused and say, hey, I don't know where your main robot project is. The correct one will be under the new namespace java /first.main.java. If it's under the old like org.frc.wklib like main or whatever, like you can just delete the old one and then just keep this one, and then you can continue with the build process and it will like work. So as overview for the namespace changes, so like a lot of the wklib job package moved from edu.w5.first to org.wklib. For C++, this is FRC to wklib. And it restructured a lot of things, so just be aware of this. So this isn't going to be, it's fairly straightforward once you understand it, but like be aware that there is going to be some effort when you're upgrading your project. So a lot of things got separated into their own like sub projects or namespaces, and the import process just tries to import like it as best as it can. But there are some mistakes as pluses and alpha, so it doesn't catch everything. Hopefully by the time the season starts, like the importer will be better, so that if you're trying to import your old project, it should be more straightforward. Or if you've already have done this by the beginning of the season, then hopefully there won't be as many changes that you need to worry about. So now I'll be kind of going over all the like namespace changes that I noticed when doing this process. So yeah, so first kind of going over the command framework and HID. Most of this is just namespace changes. The biggest thing is like command Xbox controller. Got replaced with command gamepad as a generic one. And then for the buttons, they have a button enumerator instead of with a direction, so a dot north or dot east, and then the enumeration would be like, or it was button, and then the enumeration is the direction, like north, east, south, or west, instead of like what you would probably were familiar with, is like A, B, X, or Y, or square, circle, triangle for the PS4 version. I think they're re-adding this in the next WKLib update for Alpha 7, but as of the Alpha 6, this is what they're doing. And then for society routines and stuff, like they're just like namespace and logging stuff. And then there's also like command-based version 3, but we'll not be covering that. And then, so next is driver station alerts. So it used to be everything used to be under the driver station namespace, but it got moved out, and then they're now like separate names. They're now under different namespaces. So a lot of you are probably familiar with like getting the Alliance Red/Blue for this year's game, where like each section was there was like the red side and blue side of scoring. So but now it's like changed into its own like alliance namespace, and then the enumeration is now all capital red and all capital blue instead of just like camel case red and blue. And then error reporting is now it's under its own namespace. So if you're using that to like report warnings up to your driver station, like be aware that that's also in its own namespace and that might not get imported properly. Internal backend calls for like driver stations that silence joysticks for like simulation. If you're doing that, like it got moved into the internal subpackage. Alerts and alert severity got moved in its own package, and it got renamed, and then the enums got renamed, and then generic HID was just a namespace change, and new driver station types got moved into its own namespaces. Again, like a lot of this is like a lot of changes, so just try to be aware of them and try to do them as early as possible. So robot-based class, this is more of a changes to its the framework, because now we have like timed robot, well not timed op mode robot, and then time no breaks got moved into the new systems package, and then data logging got moved into system, LEDs got moved into its hardware to LED package, simulation is now its own thing, dashboard telemetry is now under smart dashboard, and then color utilities is now it's under its own color and under WPI live instead of WPI live J only. Also, one thing I noticed is that robot init, the function, got removed in timed robot or command-based robot. This is and the recommendation from WPI live is to use just the main robot class when initializing stuff there. Yeah, and core libraries, most of you are probably won't have to deal with these, but they just got moved over. Network tables 3 is now completely removed, and then if you had an old network tables 3 stuff, you should migrate to network tables 4. Port forwarding stuff is only a namespace change, and April tags got moved to a top-level vision package. And then math and geometry, a lot of this is just like namespace changes and renames, but just be aware of them. One thing that's probably most of you will interface with is the swerve module state and swerve module positions. So those got changed, and then also the chassis speed. So they, instead of chassis speeds, it's now chassis velocities, and there's also chassis accelerations. So just be aware of those when importing your class. For those of you who are doing like a lot more simulation based stuff, like those got changed into their own like into their own their own namespace. For example, plant system modeling for linear system ID, for like creating a flywheel or a simple motors subsystem. That's now under models, and that won't get imported properly. So just be aware of that. And one thing I did notice in the pose 2D / 3D math is that you used to have an exponential function, but now they recommended you just add that to 2D / 3D, and that this is, most of you shouldn't care about that, but if you're doing some sort of like latency compensation or like shoot on the move kind of math, like that's where you'll find that kind of thing show up. And then other breaking changes I'll notice. So major language version changes. So Java is now Java version 25 instead of 17, and C++ is now version 23 instead of 20. Mostly that shouldn't really matter, but it does enable like new features from those like language versions. I know like Java has some like more advanced switch case statement handling that you can do there and stuff like that. PWM LED port counts. So Systemcore has significantly fewer physical ports than Rio. So Rio you used to have like 10 plus another 10 if you use MX like expansion port. So if you try to instantiate a port that's outside of that range, like you might see that your code crashes. Like that's one of the things I found when importing the code, is that we assigned our LEDs to like port 8 of the PWM, but the second I tried to like run it on our system core, like it crashed because of that. So just be aware of things like that. Yeah. and then remove hardware support. So all this is for like all the analog sensors that used to have like classes. Like there'll probably like a equivalent like smart IO class in WPLib for like the Systemcore equivalent, and so you're going to have to just get like import those, or you're gonna have to like use different sensors. If this is a problem, just let us know and we'll try to figure out something for you. So there are some things that got removed entirely as well. So Ramsey controller / Ramsey command. So this is for like some PID control. They recommend using the linear time variant unicycle controller instead, and I linked some instructions on how to do that. PID command, profile PID command. They recommend using control classes directly inside in the commands and subsystems instead of just using it as a command. And the motor controller group and motor controllers. Some things got renamed. Motor controller group got removed. Immutable Java units. So if you're using the units class, you may have noticed that you can't do a unit.copy anymore. So you're just gonna have to like re-instantiate a one of those units variables. And this was more of a the mutable units was more of an issue to try to deal with like the memory limitations, the older Rio, where to avoid like running out of memory. So that's kind of why they removed it. And remove dashboard.tools. So this will probably apply to a lot of you. Like so, Surfboard and Smart Dashboard, the app, are removed. So that's for like a dashboard for like showing like status of your robot. They recommend using Elastic/Advantage scope for the dashboard instead, because the old dashboards are now removed as tools. The API calls using those are, I think, they still exist. Pathweaver and Rio Robot Builder are now removed. For Pathweaver, it was WPILib's own like path tooling tool, and they recommend using either Choreo Pathway Planner or Beeline for path planning instead, because those Pathweaver, I think, was like no longer maintained. And third-party vendor changes. So neutral, this is probably the biggest one for those of you using CTRE configurations, is that the neutral mode for breaking coast is now a persistent config and not a real-time call. So like when you're setting up in motor, like that's when you would set that configuration instead of like calling it consistently, because that's technically considered like not proper use of that mode. So they recommend you set it once and not like be a repeated call. Otherwise, like it might cause like some latency issues because it's burning it into like the memory inside of the motor. So, and like because we now have like 5 CAN buses, the CAN buses argument is now explicit when you're creating the device. So, for example, like it used to be device and then just the CAN ID. Now you have to do the device, the ID, and then the string CAN bus it's on. For the CAN bus name on the Systemcore, I believe it's S0 to S4 for the 5 CAN buses, and then for Motion Core, there's like D0 to D19, but you shouldn't have to worry about the Motion Core side. And then Rev, same thing. They now require like specific CAN bus declaration because of the number of CAN buses that have been added with Systemcore. And then their old like configure overload is now removed, and they have a newer overload instead. And then for Pathplayer and Correlate, both of them have like 2027 alpha compatible releases, but not every vendor has caught up yet. I think Beeline released their update like maybe like almost a week ago, so that's fairly recent. But so check the compatibility table and Systemcore testing before committing to a library for competition. And then so now that I've kind of gone over that, I'll try to give some important debugging tips to try to make this faster. So for me, it took me a few hours, but I would probably try to dedicate an entire day to do this, because this can end up being a significant number of changes. And be wary of like trying to use an AI or LLM for like upgrading, because it might not get it correctly, because all these stuff is new and LLMs are trained on like old data. Like it might get it, but like more than likely you'll get something wrong and it might mess up your code. So just be aware of like doing this that you'll probably have to do this manually. If you want to find all your problems faster in VS Code, you just click on the little problems tab at the bottom and then filter on just errors, and then just kind of go through those one by one. If you click on the errors, it'll take you to that line in the code, and then you, at that point you can just like kind of figure out like what's wrong with that piece of code, and then like with the table I have, that should cover like the majority of the issues that like the importer didn't like cover. Some errors will only show up on runtime. It's not like the invalid port number. And some of these things you can find by like running your code in simulation. So if you search at the top bar for in VS Code, you can go and simulate your code. You don't have to have this as a super complex simulation like some other teams do, but if you run simulate and then the code crashes on like first minute or so, like you can usually tell like there's something wrong in your code and then identify it that way. So like even though your code builds, it doesn't necessarily mean that all the errors are caught. And by doing this, like by the time I got the code working on Systemcore, I only had like one bug that actually crashed, and that was because like it was something related to the robot controller, like brownout. It's the robot browned out call. And that apparently wasn't implemented in Systemcore yet, but that should be fixed by Alpha 7 with the WPL. And then the last thing I'll talk about is the new driver station software for the 2027 season. This replaces the old NI driver station. It is cross-platform compatible, so Windows, Mac OS, and Linux. But the most important thing about this is that only the Windows version will be FMS compatible. This is more of a concern for like the FTAAs and CSAs, so they don't have to like know like 3 times the network stacks of both like Windows, Mac, and Linux when like trying to debug issues on the field. But this might change in the future. But for at least next season, it will be only the Windows version that's going to be compatible. So if I close this out, go to the first driver station. Like since the first thing you'll see is like this application, this little icon, but if you click here and then press spacebar, you'll now see like the whole FMS. And then if I was connected to a system core, you would see the whole like system core status. It has the same features, or most of the same features as the old driver station. So you have a graph of like what the robot's doing. You have this little tab for like logging and like any errors or warnings that show up from a robot. You have your own like your joysticks and controller and stuff, and then like some debugging stuff. And here is like you can change this from docked or windowed, like the old driver station. And then this little debugging for like the CSAs, plus FTAs when they're like looking at your driver station on the field. And yeah, I think that covers everything. Okay, yeah, in summary, install WPLib 2027 Alpha 6, so like Alpha 7 when it releases, which I think will probably be within the next couple of days, looking at like the WPLib PRs, Flash System Core to the latest OS image, which is version 13 as of now, but it'll be version 14. Import your project, then re-add all your vendor depths, build your project, and then try to fix all the compile errors that remain from the import that didn't make it over. Search your code base for other breaking changes that might not be like importable, and like try to find the equivalents if you can, and then retest on the bench, update device firmware. All vendors should have like an alpha compatible like firmware for like the motor controller and stuff, driver controls, autonomous testing, telemetry, everything before we're trying full robot testing. And here's a list of all the references and resources that I use when importing our code. One thing that I did add from last week is 3476 mentioned that one of their students created a code migrator tool. So once you've imported the code using WPILib, you can use their own like migrator tool, and that reduces the number of errors down to like less than like 100 from like their reporting. Like I think they tested it with a couple of code bases where it's like initially 300 errors, and then it went down to like 100 or less, depending on like the complexity of the code. So, and I think that's it. Does anyone have any questions so far? Yeah, you had a question? Yeah, so the question is, if you want to temporarily move a motor to coast mode, can you do that with the new CTRE library? And the answer is yes, you should be able to do it. Just you can't. The recommendation is don't do it persistently. So like don't configure the motor like for example, when you're trying to run a motor, you're constantly sending it at the loop of the RoboRio or now Systemcore. Like the recommendation is to not do that, to not consistently configure because you might encounter like some weird latency as it's reconfiguring and then running it. So you can do it. It's just it'll probably require like some changing of your logic of like when you're implementing that. Yes, it's safe to do with your disable it. It's just like you shouldn't be calling the configurator for the CTRE motor constantly over and over again because that might be like it might cause like some weird stuttering issues when you're doing that. Yes. Yes. Yeah. Any other questions? I do not. That would probably be a CTRE question. Yeah. Any other questions? Otherwise, I'm gonna hand it back to Andrew for some of like the last notes.
Yeah, thank you, Jonathan, for giving us a nice overview of the software. So, all right, I just wanted to give a couple more Showdown specific notes. So, if it wasn't already obvious, SoCal Showdown, the only device you'll be allowed to use is Systemcore. So, that was kind of one of like the things that we try to do. We want to have like an all Systemcore competition. So, the idea is to be able to test out all the different software and just verify before the season that everything is right. So because of that, we're kind of like a little bit of a testing group, and it doesn't work really well if we have one RoboReo robot and all Systemcore robots. So if you're going to be at Showdown, hopefully you've realized that you have signed up to switch over to Systemcore, but that'll be the requirement, obviously. Some of the other things that you should be aware of, the Alpha 7 driver station, the Alpha 7 WPI lib, and the Systemcore version 14 are all going to be required. If you've been paying attention, you'll have noticed that Alpha 6 is the most recent WPI lib, and Systemcore v13 is the most recent. So this means that even if you update all your stuff right now, you will have to update your stuff at a future point. So just be aware of that. Make sure you're paying attention. We'll send out probably an email blast once all this stuff is out, just to remind you guys. But make sure you're paying attention to the Systemcore testing repo and updating when that stuff comes out. And yeah, something else to note, we'll be using the official first FMS hardware running the beta of the 2027 FMS software. This will be the only event that will be doing this, so we'll be kind of doing a little bit of a unique thing here. It might be a little bit different than the normal FMS system. We're not entirely sure. First is still working on the little details there, but just something to be aware of. Just like we will be figuring out our new hardware and trying to get it all going, the first people are also going to be trying out their new hardware and getting it all going. In their side, it's going to be on the FMS side. But just something to be aware of for the actual competition. For the actual competition, we're fortunate enough that we'll have actual Limelight staff, the people that develop the hardware, on hand for any hardware issues. So if we have anything there, they'll have extra units. I actually have extra units too if you guys have any issues. But if you do run into issues at the competition, we'll have that help there readily available. We'll also have WPI lib developers. We're having Thad House and some of the other developers you might have heard of, Peter Johnson, Joe Ross. A lot of those people will be there at SoCal Showdown. So they'll be able to provide that support if you have any kind of issues during the actual competition. If that isn't enough, we'll actually have FTAs from First and also First staff there. So it should be a great event with a lot of different support. So definitely recommend if you're just walking around the pit area, definitely like ask people, ask them how they made Systemcore, ask them about the BPI Lib things. This should be a great event where you can ask a lot of the people that actually worked on the thing and developed the thing. They'll be there at this competition. Something else to note, there will be a lights robot safety inspection just to make sure Systemcore is wired and just general safety. So we're expecting this to cover just like general like wiring, making sure you've plugged in your Systemcore to your PDP without anything in between, making sure your breakers are the correct sizes, your wires are the correct size, making sure you don't have anything crazy dangerous on your robot, making sure your batteries are properly screwed down and of the right type. It's mostly just electrical and mostly just around system core and around safety aspects. We won't be doing things like making sure your robot is in weight, although we do ask that you try to stay roughly at 120 pounds plus or minus a little bit. So just to be aware, there will be an actual inspection. You'll have to do the inspection to compete at the event. So you can do your scheduled practice match, but then if you want to do more practice matches, just like at a real competition, you have to make sure you're fully inspected. All right, support. So if you're looking for support, there's a number of ways you can get support. So pretty much every Sunday from here until competition, we'll be holding System Core office hours here at the 4201 practice field. So feel free to, during these sessions, bring your robot. We'll have our robots running. Hopefully there'll be other teams, and you can actually do your whole practices if you want to at our practice field. The sign-up link is here. But then this is also a time where Jonathan and I and some of the other 4201 mentors will be around to answer any more questions or to work one-on-one with you on your system core and try to help you work through whatever issues you have. So if you're running some roadblocks, you have some issue you can't figure out, this can be a way to get in-person support, and we can help you with whatever issue you have. The other place you can get help is making an issue ticket on the System Core testing repo. So the way you do this is the same System Core testing repo that we are familiar with here. You can go up to this Issues tab here, and you can click on New Issue. And this will allow you to enter like all the different, they'll ask you some information about just like, put a title in, put your description. But this is something that you can enter an issue ticket in. And as you can see, there's a ton of issue tickets. These issue tickets will have responses from people at First or WPI Lib people here, and they'll be able to help you with whatever issues you have. And if there's software changes that are needed or any kind of fixes, this will be the way to make it happen. This is also the place that you can put in any kind of comments of just like, I spent forever on like 2 hours on this and couldn't figure it out. It was really simple. Could you guys like modify the UI a little bit to make it like a little bit easier? This is the place where you can ask for that sort of stuff. I mean, all the WPI Lib people and all the other people are looking at this stuff. So this is the place where you can note any bugs you find or that sort of thing. And the Limelight people, Brandon and Greg, will look at this, even the CTRE people, and they'll make sure that whatever issue you're running into gets resolved. So this is a really big tool that you can actually have a lot of impact on for other teams. You guys are the beta testers. There's been an alpha test group. Now there's a beta test group, which you guys are. So this is the time where you can try and make things better for everybody else. We're really in the weeds of development, so this is the time if we want to make changes that we make them. So that way when the season hits, all the new teams start on this hardware, they don't run into the issues you've run into. So I recommend that you use this liberally, and whenever you run into issues, just put them on here. It's just better for everybody to know about the issues rather than for something that everybody just to like not hear anything and not know if it's good or bad, that sort of thing. So definitely make use of this this repo here. And yeah, if you have any immediate issues, you can reach out to me. I can help you with any hardware issues. So if your hardware breaks, I can help you like really quickly get a new piece of hardware or replace whatever you need there. So yeah, and then yeah, obviously software feedback, all that sort of stuff. Put that in the issue ticket in the System Core repo. And something else, shout out for our scrimmage. So this will be happening the weekend before SoCal Showdown. This is a great time to test, just do like a final, like all systems check of your robot. We'll be having actual matches, so you can go through the whole process of making sure your robot will drive and everything. We'll be using Cheesy Arena, which isn't quite the same as the official FMS, but it's close enough that if it doesn't work there, you'll have issues during the competition. So highly recommend if you can, try and make it out to this scrimmage. Sign up is the same as the sign up for the field, s.team4201.org/field. Just this is the same. It's also for this field is also available during the season. So if you aren't already coming to our field, you can come during the season. You can come during the off season. We always love to have people around. So the goal is to really make it a place where teams can come and get help and share ideas and really make all the boats in this LA area rise together. So yeah, please come to our scrimmage if you can. It's a great time to test your robot and work out any last bugs that you have there. Some last couple asks here. So you guys are part of the beta. Please, if you can, blog about your experiences. So the place you can do this is under the discussion section of the Systemcore testing. So we were looking at issues. Now we're looking at discussions. There's a bunch of teams that have just like gone in, like for example, let's see, this is an FTC team. Let's find an FRC team. So let's team FRC 1987. They've made just like a discussion here, and they've just entered like whenever they work through issues, like here they were installing their Halio module, for example, or I don't know, just like making notes. So this is a great time for people just to get an idea of like what you're going through, and like if you're running into issues, this is a place where you can be like, I don't know, I spent a bunch of time, couldn't figure this out, and somebody can respond to you and be like, hey, this is the thing you missed, or maybe you didn't know about this thing here. So yeah, we're always looking for feedback, especially the Limelight people. This is where you can get feedback and that sort of thing. So if you can, please make a discussion here. It's super easy, just make a discussion, that's your own. You can do whatever you want there, you can write whatever you want. But as you're going through the process of updating your WPI lib, rewriting your robot, just please blog about it here if you can. This will help everybody out as we try to understand how the beta is going. And yeah, and I guess just to further shout this out, Limelight generously donated all their hardware. We actually didn't buy any of these Systemcore units. Like your registration went to the event, it didn't go to these units. So Limelight donated them to us. They just sent us all these units. So this is their only ask for doing all the work of making sure these units came to us early and making sure they're supporting this sort of thing. It was just that you tell them about how the hardware is doing. Because they want to know. They want to know if the hardware is breaking or not doing good things. So they can make those updates before the season starts. And then if you can, another ask they made of us is try to use more than one CAN bus. Most of the alpha testers only use 1 to 2 CAN buses. So this is a big area where they need to make sure that like the rest of the CAN buses are working and that like teams are not running into too many issues trying to get multiple CAN buses going. So if you can, try to use more than 2 CAN buses, and that can really help out the hardware teams as they make sure this hardware is good for everybody. And yeah, last thing I want to do is just thank a number of folks. So thank you for the Limelight folks for their generous hardware donations and for reviewing our slides and making sure everything's correct here. WPI Lib people who have been working tirelessly year after year to make sure all the software is right, especially Joe Ross and that house for reviewing our slides here. And then yeah, all the WPI Lib contributors. So you guys can too also be WPI Lib contributors. I know some of you have made issue tickets and made pull requests into WPI Lib, but this is another shout out to continue to help with them. It's an entirely volunteer-led organization that writes all this software. So if you want to see things improved, you can make issue tickets, you can make pull requests and change the code, all these sort of things. And last shout out, I wanted to shout out, well, last week, this is from last week, last week we had to run this workshop over at Beach Cities Robotics last minute because this space wasn't open, but I guess for this, I'll just shout out 4201 and the administration here for opening up this space and allowing us to run this workshop here in this nice, awesome auditorium here. And yeah. So now we'll be going into breakout sessions. So if you want to stick around for individual Q&A, I'll be hanging out here in this general area. So feel free to ask me questions. If you're helping out the crimping workshop, you probably should head out there now. But we'll be also having a crimping workshop out in the foyer area there, not actually in the robotics lab. But this is a place. Well, I guess I should have updated this slide, didn't. But it's gonna be hosted by 4201 and 2637 this week. This is a place where you can try out both the budget crimper and the official Molex clip crimper and try to decide which one you want there. And then if you want to do Systemcore pickup, that will be outside here. But yeah, with that, that's everything I had. So thank you all for coming, and yeah.